Hello everyone. Welcome to this first video lecture series of Electronic Principle. Myself, Professor Pinkesh Patel from Electronics and Communication Department, Dharms Desai University. In this video lecture, we are going to study digital electronic system. After watching this video, one can able to understand the representation of analog and digital information or data. You can refer the listed book for the detailed explanation of the topic. The textbook is Digital Logic and Computer Design by Maurice Mano. You can also refer the reference book Fundamental of Digital Circuit by Anand Kumar. These two are the time domain representation of the digital and analog information. The given waveform plotted with respect to the time, x-axis is the time scale and y-axis is the amplitude scale. The analog signal has infinite possibility over the time as well amplitude. So at every possible value of time, there is a possibility of some amplitude value. The given analog signal is sine wave, which can be mathematically represented as y of t is equal to a sine 2 pi ft. So that at every possible value of t, there is a possibility of y of t, which is infinite possible value of time. Whereas digital data has only two finite levels are possible. At any time indexes, either your data is 0 or your data is 1. That's why digital signal can be represented as 0 or 1. Now ideally, 0 represents no voltage and 1 represents full source voltage. Realistically, 0 represent the low voltage and 1 represent a high voltage. Now one can achieve this value by on state and off state of the switch. The transistor switch which operate at high speed can achieve this value. Realistically, low and high voltage depend on logic family used like RTL, TTL, ECL, TTL and CMOS. RTL stands for resistor transistor logic, DTL stands for diode transistor logic, ECL stands for emitter couple logic, TTL stands for transistor transistor logic and CMOS stands for complementary metal oxide semiconductor. Now for an example, for TTL logic family, the input can be realized as the low voltage, that is 0. If your voltage level is in between 0 to 0.8 volt, then this can be represented as low voltage. And if your voltage level is between 2 to 5, it can be represented as high voltage level. Now, this will represent analog systems versus digital system. Now, analog system process a time varying signal that can take any value across a continuous range of the voltage, while the digital systems process a time varying signal that can take only one of the two discrete value of the voltage, that is 0 or 1, which can be represented at on and off, high and low, or true and false. One can define the systems like system is a group of circuit or interconnections of various circuit which can perform a specific task. Now these two are the analog versus digital representation. Analog signal is a continuous time varying signal, while digital signal has only two finite level at any interval of the time. Now, these are the noise immunity property of the digital signal. So if you represent your digital data like this, which can be represented as the high voltage level and low voltage level, which is 0 and 1. Now you can represent the data like this: 0, 1, 0, 1, 0, 0, 1 and 0. So if there is a possibility of some noise at any time interval, still the digital data can be correctly reproduced. So your digital signal is noise immune. This is the basic difference between analog signal and digital signal. The basic difference is an analog signal is a continuous wave that change over a time period, while a digital signal is a discrete wave that carry the information in binary from 0 or 1. In representation wise, an analog signal is represented by sine wave, like, or cosine, triangular. It can be noise signal also. A digital signal is represented by square wave. Description basis point of view, an analog signal is described by the amplitude, period, frequency and phase, while a digital signal is described by bit rate and bit interval. In range point of view, an analog signal has no fixed range and digital signal has a finite range in between 0 and 1. Distortion point of view, an analog signal is more prone to distortion, while a digital signal is less prone to distortion. The best example of analog signal is human voice, while the information processed or stored by the computer are generally in form of the digital. So these are the benefits of digital systems over analog system. It's not affected by noise, means improved quality, easy of design, data protection is more, speed, cost and size. Now let's see this video for the explanations of analog and digital signal, some basic example. Now for analog signal, this light intensity, temperature, pressure and flow rate. For an example, one rheostat is given. Now change the value of rheostat. So if you change the value of rheostat, the current is going to change in that way and light intensity is also going to vary. So by changing the rheostat at every time instant, there is a change in the light intensity. Now see some level example. If you change this slide bar, this will change the level of water inside the tank, and that's why the output will be continuously vary over the time. So these two are the example of continuous signal or analog signal. So by continuously varying this level, there has been some output current is going to measure. Now for a digital signal, typically it can be represented as 0 and 1. So it can be represented as on switch. So if you close the switch, the bulb is on. If you open the switch, the bulb is off. So the kind of 0 voltage or 1 voltage, high or low voltage level. So these two are the typical example of analog and digital signal. Now following the reflection spot. So now pause this video for a moment and answer the question. Hope you have write your answer. Now check your answer with this slide. Thank you.